Hi there, this is Ms. Page. In this lesson, we are going to focus on the idea of a net. What is a net when we're talking about solids or three-dimensional figures and how we will use them? So one of the things that we want to keep in mind about some of the basic solids that we have already learned about in our volume unit is with prisms and cylinders, we want to remember, so the question here is how many bases does a cylinder or prism have and what's true about those bases. So the idea is of the bases for a cylinder and prism, remember that they have two bases each. Now the cylinder, those bases are always the two circles that are opposite and parallel each other. With a rectangular prism, because all of the sides are rectangular, you get to choose the two opposite rectangles that would be your bases. So you can choose the top and the bottom, or you could choose to use the front and the back as your bases, or you could use your right side and your left side as your bases. What also has to be true about whatever bases you use for a cylinder or prism is that they have to be congruent to each other. So same size, same measurements, same shape, all those kinds of things. That is helpful when we are constructing a net from a solid such as a rectangular prism or cylinder. All right, so here is a definition of a net. And a net is a useful tool when looking at surface area of three-dimensional figures. So what it does is it takes and it kind of unfolds a three-dimensional figure to lay it flat and show all of the individual shapes of all of its sides and surfaces. So when you draw a net, you need to make sure that each side or face is drawn only once. That when you're drawing a net, if two sides are joined by an edge in the solid, that in the net they are also joined together. So like here, the 4 meters and the 2 meters, they meet at this point. Here, this side right here and this side right here meet at this edge. So we would be looking at all of that so that they are all connected to each other. And that you make sure that when you are drawing it, that if you were to fold it all back together, that all of the sides that you have drawn or the shapes that you have drawn fill in all of the sides of the surface of the figure, so that it doesn't, like, you don't get two tops or two bottoms and then have an open left side. There's nothing there for the left side. So that's the idea of a net. So here, what we're looking at, so one of the skills that we will use is to actually draw a net. So here we have our solid, and here we're shown we have the net. What we're asked to do here is to complete the other two sections of the table. So to name the solid that we're looking at, which would be a rectangular prism, and to describe the faces or surfaces of our rectangular prism. So one of the things about a rectangular prism that I want you to take note of is that it has 6 rectangular sides, but for sure we know that the sides that are opposite each other, such as the front and the back, the left and the right, the top and the bottom, that those would have to be congruent. So it actually has 3 pairs of congruent rectangles for sure. So that's one of the things I want you to keep in mind if we are using this strategy later on to help us find surface area of a rectangular prism. So it has 3 pairs of congruent rectangles. All right, so here in the next part of this table, we are looking at, we're given the name of the solid, a triangular prism, and the faces have been described, the sides of the prism have been described. So we have a pair of congruent triangles and then 3 rectangles. So 2 congruent triangles and 3 rectangles. Now, be aware, remember that prism and pyramid, very different. Prism has rectangular sides, but its bases can be other shapes. That's why in the previous one we called it a rectangular prism, because its bases had to be rectangles because all of its sides were rectangles. Here what this is saying, remember, is that the bases would be triangles. So there are different types of triangular prisms depending on how we draw the triangle. So we could draw a right triangle, we could draw an isosceles triangle, we could draw an equilateral triangle, we could draw a scalene obtuse triangle. So we can create all kinds of different rectangular prisms. So to keep it fairly simple, I am going to draw a right triangle here. And that's going to be the front of my prism. So what I'm going to do now is I'm going to draw lines going back. And this line right here would be behind, so I'm going to make it dashed. I made it a little too long. And then these would connect. So this is the top edge, this is the back side, bottom, back. And that creates one type of triangular prism. It's a right triangular prism. Now the net of that right triangular prism. So now you can unfold this in different ways. For example, I can unfold it so that this rectangle represents the bottom. And it's helpful to label with the part, so that's the bottom. And then I can fold out this back side, or the back rectangle, or you could call it the left rectangle. I call it left because I've got more, I can write that in there. And then this large rectangle here is going to fold out, and that would be now the right side. And then we've got these 2 right triangles. So notice the back corner there, that's this corner here, and that's where the right angle is. So this is going to be perpendicular. And that's where my right triangle is. So this is the back. And then this is the front corner, which would be right here. So that's going to be perpendicular there. And this would be the front triangle side, and that would create a net. And then what we can do is in surface area, one of the strategies we can use is to find the area of the 3 rectangles, the area of the 2 triangles, and then add them all together, and that would give us the surface area of the total prism. All right, let's take a look at what's next. Sorry about that. So here, another part of our table, we are given a description of the faces and a diagram of the net. We're asked to draw the solid and name that solid. So the idea would be, so here we have a rectangle and 4 triangles. This would be the bottom, and then these 4 triangles would fold up. Each one of them folds up and meets, so this edge meets that edge, this edge meets that edge, and so on and so forth. And so what it actually will form is a pyramid that has a rectangular bottom or base. So that's the rectangle, 2 pairs of congruent isosceles triangles. So we have these 2 smaller isosceles triangles and the 2 larger ones. So what I would do here is start by drawing my rectangular base in perspective, which means that it's going to look more like a parallelogram, like so. And then I'm going to make a point up here. This is where all of these points of these triangles are going to meet, and that's going to be the apex of my pyramid that I'm creating. And then I'm going to draw, so this would be that front isosceles triangle, and then going to the back, isosceles triangle, and also gives me the left and the right. Not maybe the prettiest pyramid, but it gets the job done. So when we name pyramids, there are different types of pyramids, remember, too. And the type of pyramid, they all have triangular sides that come to a point at an apex. And what makes them different from one another is the shape of the base. So the type of solid we have here is a rectangular pyramid. So, all right, moving on. All right, so for this part of our table, we are told that we're working with a cylinder and we're given a drawing of the cylinder. So we have to describe the faces or surfaces and also draw a net. So we're going to start with the net in this case. So one of the things that we know about a cylinder is that the top and the bottom are both circles. The question is, do we know how to describe the side of a cylinder? You know, that curved side goes all the way around, when it's all laid out flat. So what happens when it lays out flat? So imagine that you are going to cut down the side of the cylinder, and then you're going to unfold it. All right, and when you lay it out, this circle right here and this circle right here will become straight lines. And so what it actually creates is a rectangle. So this is the side of our cylinder. And then it has those two circular bases. So when it folds out, we've got one here, got another one here, and you can pretty much draw them wherever you want to. But this would be the top, this would be the bottom circle or base of that cylinder. So what we get is two circles, and they're congruent, so we could also indicate that. So we have two congruent circles and a rectangle, like so. All right, so that finishes this part of the lesson. And in the previous part, we did our cross sections and solids of rotation. So in the next lesson, we are going to start talking about calculating surface area of our solids. Have a great day.